So what we want to be able to do here is find what's called the extrema of the following functions. That is just another word for absolute max and absolute min. Basically, that's the highest point on the graph and the lowest point on a particular function. So the way we're going to do that algebraically is, this is the guidelines. It's on page 4 for following the absolute extrema. So first of all, you have to find all the critical numbers. So critical numbers are where the derivative is equal to 0, does not exist. And then you're going to go ahead and evaluate the function at each of those critical numbers. And you also need to look at the endpoints, because absolute maxes and mins can only occur at critical numbers or endpoints of a graph. And then you're going to take all those values, plug it back into the original. The smallest y value is the min, the biggest y value is the max. Okay, so let's take a look at the first problem. So step 1, find all your critical numbers. So I'm going to take the derivative, set it equal to 0, and this factors pretty nicely, and I can see easily that my critical numbers will be plus and minus 2. Now I only care about this interval, so if you end up with a number not in that interval, we don't want to even look at those. So your only possibilities for absolute maxes and mins are critical numbers, so I'm going to take these and plug it back into the original function. So I'm going to find f of 2 and f of negative 2. And this is going to be negative 16. This is positive 16. And the only other place where you can have a critical number is the endpoints. So I'm going to take my endpoints and plug it back into the original as well. So f of negative 3 is going to give me 9, and f of 5 is 65. So these are all the y values on the original function. I'm looking for the absolute max, absolute min. The smallest y value is negative 16. So this is my absolute minimum. And then highest value I see is 65, so that's my maximum. If I don't put the word absolute in front, it implies absolute. Okay, let's try letter C. So step 1 again, let's start with our derivative. So I'm going to bring down the 2/3, reduce the power by 1, and I will need to simplify it. So the only thing I have to do is, drop that to the bottom so I get to here. So the only critical number I see is x equals 1 because it makes the derivative undefined. And basically what you have at x equals 1, because the derivative is undefined, is you're going to have this cusp there. So I'm going to take that critical number, plug it back into the very original function, and if you do that, you're going to get 2. The only other places where you can have absolute max or min is the endpoint. So I'm going to take these two endpoints, plug it back into the original. And if I plug it back in, I'm going to get a 3 here and a 6 here. This is my smallest, so I'm going to call that my min. This is my biggest, that's my max. Make sure you are referring to the y values. Okay, last one. Okay, we've got a trig one, but process is going to be the same. So the derivative is going to be 2 cosine of x plus, the derivative of the cosine is negative sign, so it's going to become a plus. I have sine of 2x. I need the chain rule on the angle, so I need a 2 in front of there. This is my derivative. I need to set that equal to 0. Now, in order to solve this trig equation, I can't solve this because the angle here is x, the angle here is 2x. You will need to use an identity here. If you remember, sine of 2x is really 2 sine of x cosine of x. So this is going to stay. If I replace this with this, there's a 2 already there, so this is going to become 4 sine of x cosine of x. Now I can factor it. I see there is a 2 cosine of x that I can factor out. And I can find my zeros. So either cosine of x is 0, or I'm looking for where sine of x equals negative 1/2. And I'm only looking for angles between 0 and 2 pi. So I've got pi halves here, 3 pi halves here, and then from here I've got 7 pi 6, 11 pi 6. So again, take all of these values, plug it back into the original function. So I need f of pi halves. That's going to be 3. F of 3 pi halves, which is going to be negative 1. F of 7 pi 6 is going to be negative 3 halves. You can use your calculator to plug it back in. F of 11 pi 6 is going to give me negative 3 halves. And then I also need to check my endpoints, which are 0 and 2 pi. So f of 0 is negative 1, and f of 2 pi is also negative 1. So again, the absolute max and min is the highest point on the graph, lowest point on the graph. So you can have it occur at multiple places, but the minimum is -3/2. Even though it occurs at two different places, this is the lowest y value on the graph. The maximum, the highest y value in the graph would be 3.